Hello everyone, in today's video I'll be teaching you about raycasting. So raycasting creates a ray from one point to another, and basically you can use it to detect stuff in between, or if you want to use it for like a gun or something and you want to make it so you can detect when they hit the player, then you would use raycasting. So I'm going to show you how to do that. So to start off, for an example, I'm just going to put down a part, I'm going to anchor it, and then I'm going to put a script inside of here. So what I want to have to is when something goes on top of this or goes over this brick, I want to kill it. So if it's a player, then we're going to kill it, and if it's a part, then the part will just stay there. Actually, no, we'll destroy the part. So if the part goes on top of this, then it will get destroyed. Anything that gets hit by this array that will be going up into the air will be destroyed. So to create the ray, we have to get raycast, and what we're going to do is workspace raycast, like that, with a colon. So you're going to set this equal to a variable. Make sure you have it equal to a variable. And then first parameter is the origin. So since we wanted to come out of this part right here, the origin can be the script.parent.position, and then the direction. So the way to get the direction is the destination minus the origin, and I'll put up an image on screen right now that shows the formula. So what I want to happen is I want there to be a ray that goes into the sky. So there's no destination for that, right? You would think, oh, just put another part right here and that's the destination. No. You can use a vector3 to describe this. So I'm going to do vector3.new. And I don't want it going anywhere in the X. I don't want it going anywhere in the Z. I want it to go up on the Y. So right here, I'm making it go one stud on the Y. We want it to go higher. So I'm just going to set this to like 100. The next is the raycast parameters. So to make these, you're going to do a new variable, raycast parameters, and then equals raycastparams.new. So you don't actually type anything inside these brackets. You go outside of it, and you're going to do raycast parameters or whatever your variable was, and press dot. So right here, we have a lot of different things. First is ignore water. You can probably find out what this means. It's either true or false. It's Boolean. It ignores the water, and you can play with all of these. Brute force also basically ignores all of the can collide and collision properties of a part and does it. Respect can collide literally does what it says, determines whether the raycast operation considers a part can collide property over its can query value. But the one we're going to be doing is filter descendants instances. So this is a table, and this is a table of instances that you want to ignore. What if you only want these parts inside the table to be used? Then you change that filter type equal enum.raycast filter type, and then exclude any part that's inside here will not be looked at. Include every part inside here will be the only ones considered when hitting a part. So I'm just going to do exclude, and I'm going to do script.parent. I don't want this part right here to be affected or get destroyed by the ray coming from it. So I'm going to make sure I exclude this part so it's not part, it won't get detected by the raycast. So we're just going to put in our parameters right here. And then we're going to do if raycast. And this means it was successful. If it was successfully created a ray, then this is good. So you would always put this if statement here. And that's good. So we're going to do if raycast. That means it exists. And there's a lot of different properties up right now. And I'll put a image on screen that shows all the properties. But basically there's instance, which is the part that the ray hits. There's material, which you can guess is the material of the part. The distance, the position, and finally the normal. So the normal is like the normal vector of the intersected part. So basically this is where on the part that it hit. If you had a position, it would most likely be like random here. But what if you want to put something on the part where it hit? That's the normal. So what we're going to do, if raycast, then we're going to get our instance by doing local instance equals raycast.instance, and we're going to check that instance exists. Make sure you use the lowercase I if you have the same variable. So this will run if what we hit is still there, and we're going to check if it has humanoid. So first we're going to get the humanoid by doing instance, lowercase I, dot parent, find first child humanoid. So if you know, it would hit our leg or something. So if it hits our leg, we know that our leg is part of the character. So you can do dot parent to get the character, and then you can search through the character to find the humanoid. So if humanoid, then we can print we found a humanoid. Okay, so if you run this now, you'll see it won't work, and you'll probably be wondering why. Because if you want a ray to repeat, or you want it to keep checking, you need to put all of this inside a loop. So what we're going to do is we're going to put the actual raycast inside a loop, and I'm just going to make it a function. And then I'm going to wait every 0.2 seconds, and I'm going to call this function. Okay, so now we're going to hit play, and we'll see if it works. So I'm going to go walk up to here, and you see, it says that we found a humanoid, so that's good. It is finding us. So what we want to do now is we just want to get rid of it. So we're going to kill ourselves by doing .health equals 0. Okay, so we want to destroy any parts above it. So if it doesn't find the humanoid, that means it's probably just a normal part, and we can do instance destroy. If you don't want something to happen, pretend like it wasn't actually an instance. What we can do is if instance is a base part like that, then instance destroy. There we go. Okay, so what I'm going to do now is I'm going to click run first, actually. And I'm just going to put in a character. Rig builder. Just put in a block. There we go. Okay. So we have a little rig here. These were, just so you guys know, I'm testing the game right now. I'm in the game, so if I drag him up, then he falls back down. We're going to test it. I'm going to drag this spawn location over the ray. So you can't see rays, but it's coming from the middle of the part. So if the part was like this, it's coming from in here in the middle of the part, all perfectly in the middle. And then it's going straight up through the middle of the part. So we're just going to scale it back down. I can make it a little block like this. So it's coming out from the top of here, since that was our vector 3. And I'm going to drag this humanoid on top. And you see, he did die because the ray hit him. So remember, it's basically a beam going up. And the beam isn't as wide as the block. It's not like the beam is this. The beam is a tiny, tiny, tiny little part. Probably like only that thin. That thin, I mean. So we're going to do now is see if it destroys parts. What I'm going to do is, remember, the beam is coming from the middle, so I'm going to drag it over one. You'll see, and there we go. It got destroyed. So I wonder if I actually, let's see here, if I take this, if I turn anchor, yep, if I rotate it to face this humanoid, it won't do anything, actually. You're probably wondering why. That's because we specified that the direction was on the y-axis, so it's still going upwards. It's not coming out of here. We didn't change the whole entire direction of the array. We just changed how the part looks. So you got to make sure you know that array is different from what the size of the part is. So I'm just going to put this back down, and now I'm just going to make another part. Keep testing. So I'm going to drag this part. You see, this thing got destroyed because the ray is coming from the middle. It's not on it yet. And see there, it got destroyed. Invalid size. I wonder what we got there. That seems like it's from Roblox itself. Okay. That's not our script. Anyway, you see, it's working. So how would you use this to make it better? It doesn't seem that useful right now. So a way to use this is detecting if there's a wall in the way. So what I'm going to do is I'm going to make a wall right here. And this time I want the ray to come out this way. So I go down here on the position, and I see that it's negative on the z-axis. So I'm going to change this to negative 100. And then I'm just going to delete all of this right here. Okay. I'm going to name this part wall. And then what I'm going to do is put another part behind it. And what I'm going to do is I'm just going to name this thing. Okay. So if instance, then we're going to get our thing actually by doing local thing, which is our start equals workspace.thing. And what we're going to do is if the instance's name is equal to thing, because that's a thing, or we can just do thing like this. So if what it hit was actually this part right here, so if it hit this part, then what we're going to do is thing.color3, I mean not color3, equals color3 dot from RGB. We're just going to make it red. If it's not, then the color will go back to a white. So I think that's maybe 200. Oh, there it is. Like that. There we go. Okay. So if the part we hit is this part right here, then we'll make this part red. And if it's not, then we'll keep it white. So what I'm going to do is hit run. And you're thinking, okay, it's going to turn red because it's hitting it. No. Raycasts don't go through parts. They stop when they hit a part. So right now, the ray, I'll visualize this for you guys. The ray is coming out and it's hitting this wall and it's stopping. So basically it hits the wall and it's like, oh, we found a wall. It doesn't go straight through and continue on forever. It hit a wall and it stopped. So that's the good part about raycasting. You can detect if there's a wall in the way or something. But now, watch this. If we move the wall out of the way, it turned red. That's because it was visible. That's because it was in the view. So you see, if we put it out over here, it's still red. So we're gonna take it out of its direction. There it goes, back to white. Red, white, because it's not hitting it anymore. So another cool thing is, what we're gonna do is we're gonna change the direction to be the thing.position minus the origin, which is the script.parent.position. So basically we're subtracting this from this to get the direction. So now the ray will be facing wherever this part is. So watch this. We're gonna hit red now. And it's still good, but watch. If I bring it out here, look, it's red now because it's visible. So now, since there's a ray facing wherever it is, right now the ray's facing this way. If I move it up, or say over here, now the ray's facing this way because that's how it works. We change the direction to be equal to thing.position minus this position. So that's how you get the direction. So watch this. If I put a wall in front of this and we block it from the view, so it's coming about right here. There you go. It's out of view now. And see, if I put it back in the view, it's not going to view because it's not hitting the center. If the center gets hit about right there, now it's back to red. So that's really useful for detecting if something's being blocked. So if you had a monster and you wanted it to detect if there's a wall in front of it, you would use raycasting. So that's basically how raycasting works. And if you guys enjoyed the video, then make sure to subscribe and put any comments below if you have any suggestions on what you want to see next. And I'll see you guys in the next one. Bye bye.